Britain's secret jungle. How exotic felines adapted to the UK wilds. It's a misty November morning in the Scottish Highlands. A farmer named Andrew MacLeod is checking his sheep when he stops dead in his tracks. There, pressed deep into the mud beside a stream, is a paw print. It's enormous, 4 inches across, for distinct toe pads, no claw marks. Andrew has farmed these hills for 40 years. He knows every fox, every badger, every dog that roams this land. This print belongs to none of them. Welcome to Britain's secret jungle. How exotic felines adapted to the UK wilds. For decades, people across Britain have reported glimpses of something that shouldn't exist. Large cats, black as midnight or tawny as wheat fields, prowling through countryside that's supposed to be devoid of any predator larger than a fox. Most dismiss these sightings as myth, misidentification, or the product of overactive imaginations. But what if they're real? More intriguingly, what if these creatures have been here long enough to adapt, to evolve, to become something uniquely British? Today, we're going to explore that possibility through the lens of biology, evolution, and ecology. We're going to tell the story of how exotic felines might have survived, adapted, and thrived in one of the most unexpected habitats on Earth. Before we dive into the biology, we need to establish the premise. How would large cats have gotten to Britain in the first place? The most plausible scenario involves the Dangerous Wild Animals Act of 1976. Before this law, British citizens could legally own exotic pets, including big cats, without special licensing. Tigers in suburban gardens. Pumas in back gardens. Leopards kept as unusual pets by eccentric aristocrats and wealthy collectors. When the act passed, suddenly owning these animals required expensive licenses, purpose-built facilities, and regular inspections. Many owners faced an impossible choice: pay for compliance or surrender their animals to zoos. But there was a third option that some apparently took: release them into the wild. Imagine it: a puma, born in captivity, suddenly freed into the Devonshire countryside. A black leopard, a melanistic variant of the common leopard, released into Scottish woodland. These weren't wild animals. They were domesticated exotics facing the ultimate survival challenge. By any reasonable expectation, they should have died quickly. Britain's climate is cold and wet, nothing like the savannas of Africa or the mountains of South America. The prey species are different. The terrain is unfamiliar. There are no established populations to join, no mates to find, no knowledge passed down through generations. And yet, the sightings continue. Thousands of them, documented over nearly 50 years. Paw prints in mud. Partially eaten deer carcasses. Glimpses of large, dark shapes moving through morning mist. Enough evidence that police forces have launched investigations. Enough consistency that we have to ask, could they have survived? Let's approach this as biologists would. What would it take for exotic felines to establish themselves in Britain? What adaptations would be necessary? What evolutionary pressures would shape them? And what might they look like today, after nearly 5 decades of British winters, British prey, and British isolation? Our story begins with the founders, the first generation of released cats facing a completely alien environment. Let's focus on the most likely candidates based on sighting reports: pumas and melanistic leopards. The puma, also called a mountain lion or cougar, is nature's generalist. These cats have the largest range of any wild terrestrial mammal in the Western Hemisphere, from Canadian forests to Patagonian grasslands. They thrive in mountains, forests, deserts, and swamps. This adaptability would be crucial for survival in Britain. A released puma would likely have been young, easier to handle in captivity, more adaptable to new environments. Let's call her Morgan, and imagine her released somewhere in rural Wales in 1977. She's 3 years old, accustomed to being fed processed meat, and has never hunted in her life. Morgan's first challenge is immediate. She's hungry. Captive cats are fed once a day, sometimes every other day. In the wild, she needs to hunt. But hunt what? Her instincts tell her to target prey animals, but she's never had to stalk, ambush, and kill. Here's where evolutionary adaptation begins, not over generations, but within a single lifetime through phenotypic plasticity, the ability of an organism to change its behavior and even physiology in response to environmental conditions. Pumas are ambush predators with excellent learning capacity. Morgan would start with the easiest prey, rabbits. Britain has millions of them. They're relatively slow, and they're abundant in the Welsh countryside. Her early hunts would be clumsy, unsuccessful, but each attempt teaches her. She learns to approach downwind. She discovers that rabbits freeze when they sense danger, giving her a split-second advantage. She refines her pounce timing. Within weeks, she's catching enough rabbits to survive. Within months, she's mastered rabbit hunting. But rabbits are small, maybe 3 pounds of meat each. She needs several per day. Her metabolism, evolved for larger prey, drives her to be more ambitious. This is where Morgan's story becomes a tale of adaptation. Britain doesn't have the large herbivores that pumas evolved to hunt. No elk, no deer of comparable size to American mule deer. But Britain does have roe deer, weighing perhaps 40 to 50 pounds, and fallow deer, which can reach 130 to 200 pounds. Morgan's first encounter with a roe deer is transformative. She's been tracking scent through a forest when she spots a young buck grazing in a clearing. Everything in her biology tells her this is prey. The size, the movement, the vulnerability. She stalks closer, using techniques honed through thousands of rabbit hunts but scaled up. The attack is imperfect. She misses the ideal neck bite and has to wrestle the deer to the ground. But she succeeds. For the first time since her release, she eats until she's genuinely full. One deer provides what 50 rabbits would, and she doesn't have to hunt again for 3 or 4 days. This is a crucial adaptation point. Morgan's behavior shifts. She begins actively seeking deer rather than settling for rabbits. She learns their patterns, where they feed at dawn, where they bed down during the day, which trails they follow to water. She discovers that deer are most vulnerable during the winter months when they're weak from limited forage. But here's where British ecology creates a unique adaptation pressure. British deer populations are managed by humans. Hunting seasons, culling programs, and habitat management mean that deer distribution isn't random. It's concentrated in certain areas, particularly estates and forests managed for game. Morgan gravitates toward these areas. Without realizing it, she's selecting habitat based on human-influenced prey density. This creates a feedback loop. She has more hunting success in managed landscapes, so she spends more time there, so she becomes more familiar with human proximity. This is how a wild puma begins the transformation into a British puma, by adapting not just to British prey, but to British human-wildlife dynamics. Now, Morgan's not the only cat released into the wild. Across Britain, between 1976 and 1985, let's hypothesize that perhaps 30 to 50 big cats were released, mostly pumas and leopards, with a few other species mixed in. They're scattered across Scotland, Wales, rural England. Most die within the first year. Starvation, vehicle strikes, illegal shooting by farmers, or simply the stress of transition. But some survive. Some, like Morgan, figure out the hunting. They find territories with sufficient prey. They endure the cold, wet winters by growing thicker coats, phenotypic plasticity again. The same individual cat developing heavier fur in response to climate. And here's the critical question for population establishment. Can they find each other? Can they reproduce? Pumas are solitary animals. Males maintain territories of 50 to 100 square miles. Females have smaller territories that may overlap with the males. They find mates through scent marking, scrapes on the ground marked with urine, scratch marks on trees. In the vastness of the American wilderness, this system works. But in Britain, the country is smaller, more fragmented by human development. Roads cut through potential territories. Cities create barriers. For our hypothetical population to establish, released cats would need to be in relatively close proximity, close enough that scent marking could facilitate encounters. Let's imagine Morgan, now well established in rural Wales, encounters scent marks from another puma, a male, released a year after her, 30 miles away in the Brecon Beacons. We'll call him Arthur. His territory overlaps the edge of hers. During breeding season, when female pumas become receptive, Morgan's scent changes. Arthur detects this. They meet. They mate. And 7 months later, in a dense thicket in the Welsh hills, Morgan gives birth to 3 cubs. These cubs represent the true beginning of adaptation. They're not captive-released exotics learning to hunt British prey. They're born into this environment. They'll learn to hunt roe deer from infancy. They'll develop thicker coats from kittenhood. They'll imprint on British landscapes as home. This is generation 1 of British pumas, and this is where evolutionary adaptation truly begins. Morgan's 3 cubs, let's call them Branwen, Taliesin, and Rhiannon, face a Britain that's simultaneously hostile and opportunity-rich. They represent the first generation of large felids truly adapted to British conditions from birth, and natural selection will be merciless in shaping their survival. Evolutionary adaptation doesn't happen gradually and peacefully. It's a brutal process of differential survival. The individuals best suited to their environment live long enough to reproduce. Those less suited die. Over generations, the population shifts toward traits that enhance survival. For British big cats, several environmental pressures would drive rapid adaptation. Climate adaptation. Britain's weather is cold, wet, and unpredictable. Winter temperatures regularly drop below freezing. Rain is frequent year-round. Unlike their ancestors' native habitats, there's no dry season, no predictable warmth. Prey availability. British prey species are smaller and distributed differently than American or African prey. Hunting strategies must adapt. Human proximity. Britain is densely populated. Unlike vast wilderness areas, British cats must navigate a landscape dominated by humans. Farms, roads, villages, managed forests. Limited genetic diversity. With a small founding population, genetic diversity is low. This creates vulnerability but also allows beneficial mutations to spread rapidly. Let's explore how each pressure shapes our British cats over subsequent generations. Branwen, Taliesin, and Rhiannon experienced their first British winter at 6 months old. For comparison, pumas in their native range experience winters, but even in northern climates like Montana or British Columbia, they can seek shelter in rock caves, and prey remains relatively abundant. British winters are different. It's not just cold, it's wet cold. The kind that penetrates fur and saps body heat. Snow is inconsistent, Instead, there's frequent freezing rain. This presents a physiological challenge. Taliesin, the smallest of the three cubs, struggles. He's less efficient at maintaining body temperature. During a particularly harsh January, he burns through his fat reserves trying to stay warm. Food is scarce, deer are in their winter poor condition, and catching them requires more energy expenditure. Taliesin doesn't make it to his first birthday, but Branwen and Rhiannon do. Why? They happen to carry slightly different genetic variations affecting their fur density and their metabolic efficiency. Branwen's coat is notably thicker than her siblings, an expression of genes that in their ancestral population would have been unremarkable but in Britain become life-saving. Rhiannon has a different advantage. She's more efficient at converting food into body fat during autumn, when prey is abundant. She enters winter with better energy reserves. These differences seem minor, but they're the raw material of evolution. Branwen and Rhiannon survive to reproduce. Their cubs inherit their advantageous traits. Over just 10 to 15 generations, perhaps 30 to 40 years, the British puma population would shift toward individuals with denser fur, better fat storage, and more efficient metabolism in cold, wet conditions. We might expect other physiological changes too. Paws might become slightly broader to distribute weight better on muddy ground. Britain's terrain is often waterlogged, unlike the firmer ground of American mountains or deserts. The nasal passages might adapt to warm and humidify the cold, damp air more efficiently. These aren't dramatic changes. A British puma would still be recognizably a puma. But measured carefully, comparing our hypothetical British population to their American cousins, we'd see subtle but consistent differences, the beginnings of subspeciation. Now let's turn to hunting. This is where behavioral evolution intersects with ecology to create something uniquely British. Rhiannon, now mature and establishing her own territory, faces a hunting landscape very different from what her mother Morgan initially encountered. The prey base has shaped her from cubhood. She's never seen an elk or mule deer. Her entire hunting education centered on British species. Roe deer become her primary target. They're abundant in British woodlands, typically weighing 30 to 60 pounds, small enough to be vulnerable to a solo hunter, large enough to provide substantial calories. But roe deer behavior differs from American deer species. They're browsers rather than grazers, feeding on woodland plants. They're incredibly alert and quick to flee. Rhiannon develops a hunting strategy optimized for these conditions. Rather than the long-distance stalks American pumas use in open terrain, she perfects short-range ambushes in dense cover. British landscapes, hedgerows, thickets, ancient woodlands, provide excellent ambush opportunities. She learns to use weather to her advantage. British mist and rain reduce visibility and mask sound. On foggy mornings, her success rate increases dramatically. She begins hunting preferentially during poor weather, a behavior that would be counterproductive in many climates but is advantageous in Britain's perpetually damp environment. Over generations, cubs that inherit temperaments suited to patient, close-range ambush hunting survive better than those that prefer the pursuit-style hunting of their American ancestors. The British puma becomes a mist hunter, a shadow in the rain, perfectly adapted to exploit Britain's notoriously bad weather. But there's another prey source Rhiannon discovers: livestock. This is where human proximity creates both opportunity and danger. British agriculture is dominated by sheep farming, particularly in Wales, Scotland, and northern England, precisely the areas where our hypothetical cats would establish. Sheep are numerous, poorly defended, and nutritionally rich. For a hungry cat, they're incredibly tempting. Rhiannon's first sheep kill is almost accidental. She's tracking roe deer scent when she encounters a small flock grazing near woodland. The sheep are oblivious. The temptation is irresistible. The kill is easy, far easier than hunting deer. But this brings human conflict. The farmer discovers the killed sheep and knows immediately it wasn't a fox or dog. The kill pattern, the precise neck bite, the feeding pattern, suggests something much larger. He reports it. Suddenly, there's attention, investigation, perhaps even organized hunting efforts. This creates intense selective pressure. Cats that repeatedly kill livestock become targets. Those that avoid livestock, or kill only occasionally and discreetly, survive. Over generations, British cats might evolve behavioral caution around livestock, not avoiding sheep entirely, but recognizing them as high-risk prey to be taken only when deer hunting is unsuccessful. This is human-driven selection, as powerful as any natural pressure. The British cat population becomes behaviorally adapted to coexisting with agriculture, taking enough livestock to supplement their diet but not so much as to trigger sustained human retaliation. Now let's talk about the black cats, the melanistic leopards that feature so prominently in British big cat sightings. Melanism, black pigmentation, is a recessive genetic trait found in several big cat species, most notably leopards and jaguars. In typical leopard populations, melanistic individuals are relatively rare, perhaps 5 to 10% of the population. But here's where Britain creates a unique evolutionary scenario. Let's introduce another character, Shadow, a melanistic leopard released in Devon in 1978. Shadow faces the same challenges as our pumas: climate adaptation, prey learning, territory establishment. But he has one advantage: his black coat. In Britain's heavily forested, overcast, frequently misty environment, Shadow's dark coloration provides superior camouflage compared to normally spotted leopards. The British landscape, particularly ancient woodlands with dense canopy, is darker than African savanna or Asian forests. Shadow can approach prey more closely. His ambushes are more successful. He survives. He finds a mate, a normally colored female leopard, released separately. Their offspring include both normally spotted and melanistic cubs. But the melanistic cubs have higher survival rates. They hunt more successfully. They avoid detection by humans more easily. Over generations, this creates selection pressure favoring melanism. In a normal leopard population, melanism remains rare because it's disadvantageous in many environments. Black animals overheat more easily in sunny climates, and in open terrain, spots provide better camouflage. But in Britain, the advantages outweigh the disadvantages. The climate is cool. Overheating isn't a concern. The terrain is forested and dark. Black provides excellent camouflage. The melanistic allele spreads through the population. Fast forward 30 years. If we could survey our hypothetical British leopard population, we might find that 50, 60, even 70% are melanistic, a dramatic shift from their ancestral population. This is called the founder effect combined with selective pressure, and it's a classic mechanism of rapid evolutionary change in isolated populations. This would explain why British big cat sightings so overwhelmingly describe black cats. It's not just that black cats are more noticeable or memorable. It's that in the British environment, black cats genuinely dominate the population. But there's a genetic cost. With a small founding population and strong selection for a recessive trait, genetic diversity plummets. The British leopard population becomes increasingly inbred. This brings vulnerability, reduced disease resistance, increased likelihood of genetic disorders, lower reproductive success. Some cubs are born with defects. Some adults die young from genetic conditions. The population growth rate slows. This is the evolutionary price of adaptation in isolation. Beneficial traits spread quickly, but harmful traits can too. Yet the population persists. Why? Because Britain, despite its challenges, has one critical advantage: absence of competition. In Africa, leopards compete with lions, hyenas, and wild dogs. In Asia, they face tigers and dholes. But in Britain, there are no other large predators. No competition for prey. No risk of being killed by a larger carnivore. British cats can expand into every available niche without contest. This ecological release, freedom from competition, compensates for genetic vulnerabilities. The population doesn't thrive, exactly, but it endures. Small numbers, scattered territories, but persistent across decades. By now, our hypothetical British cats have been here for 4 to 5 years. That's perhaps 15 to 20 generations, enough time for measurable evolutionary change. They're still pumas and leopards, but they're becoming distinctly British. Their coats are heavier. Their behavior is adapted to British prey and British weather. Their population structure reflects Britain's fragmented landscape, small, isolated groups with limited gene flow between them. They're becoming a new subspecies, shaped by one of the most unlikely evolutionary experiments imaginable: apex predators adapting to a land that supposedly has no place for them. Let's step into the present day and imagine what life looks like for our evolved British cats. Meet Gwyn, a 4th-generation British puma living in the Scottish Highlands. She's descended directly from our Morgan and Arthur, carrying forward their genetic legacy and the accumulated adaptations of 4 to 5 years of British evolution. It's February, the hardest month. Dawn breaks late at this latitude, around 8 in the morning, but Gwyn has been active since 4. She's learned, as her ancestors learned, that hunting before dawn is most productive. Deer are creatures of twilight, and in the pre-dawn darkness, they are vulnerable. Her territory spans about 30 square miles of mixed habitat, moorland, forestry plantations, and patches of ancient Caledonian pine forest. It's not prime habitat by American standards. No vast wilderness, no abundance of prey, but it's hers, and she knows every gully, every deer trail, every good ambush point. Her coat is thick, far thicker than her American cousins. If you could measure it, you'd find her guard hairs are longer, her underfur denser. This is no longer just phenotypic plasticity, the individual response to cold. This is genetic adaptation, coded into her DNA, inherited from generations of winter survivors. She moves through morning mist that clings to the heather. Her paws are slightly broader than her ancestors, distributing her weight better on peaty soil. She pauses at a stream, lapping cold water, then continues along a deer trail she's been monitoring for days. There, 50 meters ahead, a roebuck. His in poor condition, ribs visible through his winter coat. The winter has been harsh, and he's weakened. Gwyn drops into a stalk. Her movements are economical, practiced. Unlike a young, inexperienced cat, she knows exactly how close she needs to be before her rush. 40 meters. 30. The buck's ear twitches. Has he detected something? Gwyn freezes, becomes a statue. The buck relaxes. 25 meters. Close enough. The rush is explosive. 20 meters covered in perhaps 2 seconds. The buck startles, begins to flee, but is weakened and Gwyn is fast. She intercepts him, her jaws closing on his throat. It's over in less than 30 seconds. This is the moment that justifies days of searching, hours of waiting, the constant energy expenditure of winter survival. She'll feed well for the next 3 days, then hunt again. But notice what didn't happen. No chase through open terrain. No long pursuit. This was a close-range ambush in heavy cover, using mist as concealment. This is the British hunting method, refined over generations. One of the most remarkable aspects of our hypothetical British cat population is its invisibility. If these cats exist, they've mastered the art of remaining unseen in one of the world's most populated countries. How is this possible? Several factors work in their favor. First, population density is likely extremely low. Even optimistic estimates, based on habitat availability and prey density, suggest perhaps 50 to 100 large cats scattered across all of Britain. For context, that's roughly 1 cat per 1,000 square kilometers. In such low densities, encounters with humans would be genuinely rare. Second, these cats are largely nocturnal and crepuscular. They're most active when humans are least active. Even in areas where their territories overlap with human activity, temporal separation reduces encounter probability. Third, British cats have evolved, behaviorally if not genetically, to avoid humans. Remember our selective pressure discussion? Cats that were bold around humans either got shot, captured, or otherwise removed from the breeding population. What remains are the cautious, the timid, the ghosts. There's a fascinating parallel here with other cryptic predators. Consider the leopards of Mumbai, India. Leopards live within the city limits, hunting dogs and pigs, yet most residents never see them. Leopards have learned to navigate urban environments, using storm drains as corridors, hunting at night, avoiding detection. If leopards can remain largely invisible in a city of 20 million people, is it so implausible that a tiny population could hide in the British countryside? But invisibility isn't complete. This is where the sighting reports come in. Over the years, thousands of people have reported seeing large cats in Britain. Most are probably misidentifications, a large dog seen in poor light, a normal house cat appearing larger than it is due to optical illusion, or simply imagination. But some reports are more credible. Experienced outdoors people, farmers who know their land intimately, wildlife professionals. They describe animals that behave like large cats, that leave evidence consistent with large cats. Let's examine a hypothetical but plausible scenario. In 2019, a farmer in Gloucestershire discovers a roe deer carcass. It's been partially eaten, and the kill pattern is distinctive, a powerful bite to the throat, feeding beginning at the rump, ribs exposed where large amounts of meat have been consumed. He knows foxes didn't do this. Badgers didn't do this. This looks like a large predator. He sets up a trail camera. For 3 months, nothing. Then, one foggy March morning at 5:47 a.m., the camera triggers. The image is partially obscured by mist, but it shows something large, low-slung, moving with feline grace. The body structure is wrong for a dog. The movement is wrong for any domestic animal. The image circulates online. Skeptics point out it's blurry, inconclusive. Believers argue it's exactly what you'd expect: brief, unclear evidence of an animal that's evolved to avoid detection. Neither side can prove their case definitively. This is the nature of cryptic wildlife. True absence of evidence isn't the same as evidence of absence, but equally, ambiguous evidence isn't proof of presence. The scientific method demands reproducibility, clear documentation, physical evidence. And that's where our British cats remain frustratingly elusive. If British big cats exist, they face a serious problem: genetic diversity, or rather, the lack of it. Let's talk numbers. A viable breeding population of large carnivores typically needs a minimum of 50 individuals to avoid severe inbreeding depression in the short term, and hundreds to maintain genetic health across centuries. Our hypothetical British population is far below this threshold. This creates several problems. First, inbreeding increases homozygosity, individuals carrying two copies of the same alleles. When those alleles are deleterious, this causes genetic disorders. We might expect to see British cats with higher rates of congenital defects, reduced fertility, and shorter lifespans compared to healthy wild populations. Second, reduced genetic diversity limits evolutionary potential. When a new disease emerges or environmental conditions change, populations with high genetic diversity have a better chance of containing individuals with resistant alleles. Our British cats lack this buffer. The Florida panther offers a cautionary tale. By the 1990s, Florida's puma population had dropped to perhaps 20 to 30 individuals. Inbreeding became severe. Males showed reproductive defects. Heart problems became common. The population was on the brink of collapse. Wildlife managers intervened, introducing 8 female pumas from Texas to increase genetic diversity. It worked, the population rebounded, and genetic health improved. This demonstrated both the danger of small populations and the possibility of recovery through careful management. Could British cats receive similar help? It's an interesting thought experiment. If we accepted their existence and wanted to ensure their survival, we might consider genetic rescue, introducing new individuals from healthy populations to increase diversity. This would require capturing or importing pumas or leopards and releasing them into British territories. Habitat connectivity, creating wildlife corridors to link isolated populations, allowing gene flow between groups. Active population monitoring, using camera traps, genetic sampling from scat or hair, and tracking to understand population size and health. But all of this assumes official recognition of these animals' existence and protection rather than persecution. Currently, if a big cat were definitively proven in Britain, the legal status is unclear. Are they invasive species to be removed? Are they wildlife to be protected? The ambiguity itself is a form of threat. So what does the future hold for our hypothetical British cats? Several scenarios are possible, ranging from continued ghost-like existence to gradual extinction to, most intriguingly, eventual recognition and acceptance. Scenario 1. Gradual extinction. Without genetic rescue, small populations facing inbreeding depression often spiral toward extinction. Each generation becomes slightly less fit. Reproductive success declines. Individuals die younger. Eventually, the population can't replace itself, and it fades away. If British cats exist, this might be their trajectory. They've persisted for several decades, but that doesn't guarantee indefinite survival. A few harsh winters, a disease outbreak, or simple bad luck with reproduction could push them over the edge. We might already be seeing the end game. Perhaps peak population was in the 1990s or early 2000s, and numbers have been declining since. In this scenario, the sightings will gradually decrease, become less frequent, until one day they stop entirely, and we'll never know for certain whether they were real. Scenario 2. Precarious persistence. Alternatively, the population might stabilize at very low levels. Not thriving, but not dying out, existing in a kind of ecological limbo. Small enough to remain nearly invisible, large enough to maintain breeding. This could continue indefinitely. Britain's landscape, despite human dominance, still contains considerable wildness. Vast tracts of Scottish highlands, Welsh mountains, English moorlands. With careful behavior and low density, a ghost population could persist for generations. Scenario 3: Recognition and adaptation. The most optimistic scenario involves eventual definitive proof, a road-killed specimen, clear trail camera footage, DNA evidence from prey remains, that forces official recognition. This would create a fascinating conservation dilemma. These animals aren't native, but they've been here for decades. They've adapted. They've arguably become part of the ecosystem. Do we remove them as invasive species, or do we accept them as established wildlife? There's precedent for accepting introduced species that have naturalized. Ring-necked parakeets now nest in London parks, exotic birds that escaped captivity, established breeding populations, and are now accepted features of British urban ecology. If British cats received similar acceptance, we might see them transition from cryptid to conservation concern. Protection rather than persecution. Study rather than dismissal. Perhaps even management to ensure genetic health and prevent livestock conflict. In this scenario, Britain's secret jungle becomes official. The cats emerge from shadow into science. And future generations might look back and marvel that there was ever doubt about the leopards of Devon or the pumas of the Highlands. Whether British big cats exist remains unproven. The evidence is tantalizing but inconclusive. The biology is plausible but unverified. We're left in that uncomfortable space between skepticism and possibility. But here's what's fascinating. The story we've told today isn't just about cats. It's about evolutionary biology, about how species adapt to new environments, about the resilience of life in unexpected places. If exotic felines were released into Britain in the 1970s and 80s, the biological challenges they faced were immense. Climate, prey, human proximity, genetic isolation, each represented a potential extinction filter. The probability of survival, let alone establishment and adaptation, was low. Yet the core question remains compelling. Is survival impossible or merely improbable? Evolution doesn't care about probability. It only cares about what works. If some individuals could hunt British prey, withstand British winters, and avoid British humans long enough to reproduce, then adaptation would follow. Not inevitably, not easily, but possibly. And in biology, possible is sometimes enough. Perhaps there are no big cats prowling British hills. Perhaps every sighting is misidentification, every paw print a hoax, every mysterious kill the work of dogs or other explanations. That's the simplest answer, and simplicity often proves correct. But perhaps, just perhaps, there are shadows in the mist. Perhaps Morgan's descendants still hunt the Welsh hills where she once learned to take roe deer. Perhaps Shadow's melanistic offspring still slip through Devon forests. Perhaps evolution, that relentless tinkerer, has crafted something new. The British puma, the Highland leopard, creatures shaped by rain and heather rather than savanna and mountain. If they exist, they're a testament to life's adaptability. If they don't, they're a testament to humanity's need for wildness, our desire to believe that mysteries remain even in our thoroughly mapped world. Either way, the biology is real. The evolutionary pressures we've discussed would operate exactly as described if the cats existed. The adaptations we've imagined are grounded in solid science. This story may be hypothetical, but the principles are genuine. So the next time you're walking through British countryside on a misty morning, and you catch a glimpse of something large and low moving through the heather, something that doesn't quite move like a dog. Remember this. Whether or not Britain's secret jungle exists, the biology that could create it is absolutely real. Thanks for watching. If you found this biological thought experiment fascinating, please like, subscribe, and let me know in the comments. Do you think big cats could survive in Britain? Have you ever seen something that made you wonder? Until next time, keep looking at the world through the lens of biology, because the truth, whether about cryptic cats or any other mystery, always lies in understanding how life works.